take credit for your basic process design, then you can take credit for the basic process control system, you can take credit for alarms, unless they're part of the control system, in which case you can't take credit twice because they're, they're related to each other. Then you got your safety instrumented functions, you got your physical protection, and then your other physical protection that's, so relief devices would be active type devices, and then nights would be not active. And then you got your response. Now, in reality, the community response, I don't think that's all that, well, I guess it is. When we had that explosion around in Groves, was there a community response? Was there a plant response? And was there a community response to that? Do y'all remember? Yeah. Was there a plant response? Yeah, so the plant response was them trying to put out the fire. Or deciding to try to move as much material away from it as possible, trying to cool off the surrounding things, trying to mitigate it a little bit. But the community response, do you remember what they made us do? If you lived in that area?
Evacuate?
Yeah, you had to evacuate.
During Thanksgiving too.
Yeah, it was Thanksgiving. We had Thanksgiving in the apartment. Not apartment, in a hotel. Thanksgiving in a hotel. No problem. So it's important that the IPLs, and they call them IPLs, right? What does IPL stand for? Yeah, Independent Protection Layer. You might as well get used to that one. So IPLs is a thing. They have to be independent. That's the most important one. They have to be independent. But if you meet those criteria, then the calculation is very simple. It's just you just multiply the probability of failure on demand of all of the different layers. So it's really easy to calculate. So let's say, what we need, we need some scenarios, we need initiating events, we need IPLs and probability of failure of demand on those IPLs. Let me tell you, shutdown systems, do shutdown systems have a probability of failure on demand? Or are they just always work? Yeah, your initial idea would be, well, shutdown system, it always works, right? Well, what if you have an unrevealed failure? Is it gonna work then? No. Shutdown systems have a probability of failure on demand, and that probability of failure on demand depends on how often you test them. And you have to test them all the way to the final control element. There was a case, the AICAT meeting, and the consultant was talking about a case he had where somebody was suing the company because they had a shutdown system for a rail car filling station. So they had a solenoid valve there, and they were supposed to be testing it at a certain frequency. So, but it's a lot of trouble to actually shut the solenoid valve apparently, or to open it up and see if it actually shut. And so they were relying on the little green light that would come on saying that it was being shut. Well, it turned out when they needed it, it didn't work. And they opened up the solenoid valve, it was all corroded and it didn't even move. It was all torn up. And so they were testing it, but they didn't test it all the way down to the final control element. They didn't make sure that that solenoid valve actually shut, and then it bit them because it was an unrevealed failure sitting there. So you have to test all the way out to the final control element. A lot of companies don't like to do that. But if you don't do that, then you really don't know what your probability of failure on demand is, and it's almost certainly not what was calculated for that system. And so you probably are running at a higher risk than what you thought you are. Anyway, okay, so here's some examples of, initiating events. Pressure vessel residual failure, piping residual failure, and this is, a per year number that you would use as your layer of protection. A lightning strike, a safety valve that opens sporadically, cooling water failure, pump seal failure, unloading hose failure, basic process control system instrument loop failure, regulator failure. Let's see, which one of these goes with like our pump that we were doing? What failed when we were looking at our feed pump to our crew tower? Could have been the pump failed, huh? Would a pump seal fail? Do that? Would we have to shut down the pump if the seal failed? With a basic process control system instrument loop failure, would that fail? Would a regulator valve failure, would that fail? Okay. Yeah, I think it would. All right, and interesting too, that operator failure has a big range from 1% of the time failure to a lot lower per opportunity. So the 1% is typical, but if the operator's under stress, it could be 1 out of 10 times that they fail. So you have to consider that. Okay, rules for the IPL, they have to be truly independent. And let me ask you this, so a lot of DCS systems and safety systems, they're putting in the same box anymore. I mean, I really hated that idea when they started doing that 20 years ago. I thought that was a terrible idea. Do you think it's really independent when they do that? No, I don't think so. The frequency reduction is typically 1%. That goes into cell levels, but we'll talk about that later. But for an operator response, it may be 10% reduction. And the key here, you cannot count the BPCS. What was a BPCS? It was a basic process control system. So here's some IPLs. You got a dike, and they're giving you a 10 to the minus 2 probability of failure on the man of the dike. Here's a relief valve. What's the probability of failure on demand of a relief valve or a rupture disc? 10 to the minus 2. What's the probability of failure on demand of the basic process control system? 10 minus 1. How about human action within 10 minutes? 10 minus 1. Human action within 40 minutes? 10 minus 1. Okay. So these are all IPLs that we can take credit for, potentially. I mean, if you have them, right? And it just, this is the typical layer protection analysis table that you would put in. You say, this is my initial event, this is my initiating cause, its likelihood, and then these are my protection layers, however many there are. And you just multiply them together. And that gives you the mitigated likelihood. Okay. So we really need to do this kind of on one of our we've got a little less than 30 minutes. So I need an NGL and a crude example. Where do we start? Where do we get our scenario from that we're gonna have to protect against?
The gravity cause.
What did we do last time? We had our hats on, right? So what was our hands on for the crude system? What was the hazard associated with the crude system? Let's see, who did that? Ronald, who was up here drawing that? What was the hazard?
I would say overheat of the furnace.
You wanna write down what our hazard is over here? Or you wanna volunteer somebody else to do this for the crude? Who else is crude and wants to do it?
I want to volunteer Ryan.
Yeah, so volunteer someone else to do it, and then, who else is doing crude and wants to do it?
I think Ryan should do it.
Yeah, Ronnie.
Yeah, Ryan. It's unanimous.
Everybody's up, don't look at me, don't look at me, don't look at me. Okay, well, let's see if we can figure this out anyway. What's our initial event? Help me out here, what's our initial event? What was our event? I think our event was pump failure, wasn't it? That was one of them, or it could have been a controller failure, so which one is it? Let's go look and see if we can figure out a failure rate from an initiating event. What's an initiating event you wanna use? You could say it's a pump seal failure, or you could say it's a basic process control system instrument load failure. Which one do you want? Pick one.
Pump seal.
Pump seal failure? Alright, so then our, per year initiating event is 10 to the minus 1. Okay, so what did we say? We said pump seal failure? So I'll write that down. So it's a pump seal. And our, frequency is 10 to the minus 1 per year. All right, that's our initiating event. So we write that down. It's right here. All right. So 10 to the minus 1. Pump seal failure. Well, no, the event, the initiating cause of the pump seal failure. The event would be something more significant, like our, whatever we decided happened if this pump failed, right? So this is how often it might, this is the likelihood that that pump seal's gonna fail. That's on a per year basis. Now, if it fails, like, that often, is that a lot? Is that a lot of times? I mean, is that a lot to expect to have a fire? You wanna have a fire that often? Yeah, that's probably not good. So we have to have some things to mitigate. So we have to have some of these IPLs. So what are some examples of the IPLs that we might use? But it depends on where we said we got our fire. I mean, if the fire happened because the pump seal failed, then would a dike help? I mean, it might. I don't think they put dikes around pumps, do they? So can we use any of these things? Any of these IPLs helpful? Do pump seals fail in the plant? Do they? Yeah.
Oh, yeah.
So what do they do to mitigate the effect of a pump seal failure? What happens? Pump seal failure. What's going on? What are you gonna do?
Yeah, isolate.
Who shuts it down? Operator. The operator shuts it down. What is that called when the operator does something? It's probably called a human action, okay? How long are you gonna give them to shut that pump down?
3 minutes.
Immediately.
More like 3 days on
At the pump at all times.
Yeah, so we've got two options here. Really, you need them to have it shut down as soon as possible, right? You don't want crude oil all over the place, it's a big mess. It could be an environmental issue too, so. This is not process design, it's not basic process control system, it's not alarm. How do you know that that pump still failed?
Oh, pressure. You know, pressure. The pressure change. And then also you'll see, it'll be leaking and yeah, and your flow.
How does the operator know it? I mean, how do they know to go out there and look at it?
Just gotta know.
I guess it depends on how bad it is, right? If the pump seal fails and then you see an immediate response on the pressure, how could you make the operator know about it? You know, we're assuming it's a big failure. The pump seal failed so bad that it's leaking all over the place and it's not putting any pressure whatsoever. It's all just bleeding off into the, what would you see on the inside? Maybe we need more information. We've got a pump here, it's a big pump.
Like on the DCS?
Big pump. Right, got a control valve here. Flow control. Okay, the egg pump. Pump seal fails. Oil's going all over the place. Right? what do you see in the DCS?
Your valve's gonna, open all the way.
Valve opens all the way. Flow goes down. So the output goes up, the flow goes down, goes to operator duty.
Oh, crap. Where'd my flow go?
Yeah, so the operator sends the outside operator outside to go look at it, is what he does, okay? And then, how did he get alerted to that fact?
Probably
Is the basic process control system, is that gonna help us? It's actually kinda working against us, so I don't think it's helping us here, right? I mean, it just opened the valve more, right? What about an alarm? Do you think that they might see an alarm if the phone drops off?
Yeah, maybe.
I bet they would. No?
I mean, yeah. You said you bet they would, so I would bet so as well.
They would silence it?
Oh, I don't know if they would silence it, probably.
Okay, so if you've got alarm, what's the failure rate of an alarm? Where's the alarm reside? Did we do alarm rationalization in this?
Yeah, we did.
Where were those alarms at? Can you see anywhere on here where the alarms might be?
Yeah, on the flow control.
Well,
are you
they're on the basic process control system. That's where they're at. And so 10 to the minus 1, because we have an alarm. Is that good enough?
So we're gonna do the mitigated event likelihood.
I guess it depends on how bad it is, and it does depend on how bad it is. Let me see if I've got a table here somewhere about how bad it is. No, I just go talk about safety. I guess I'd have to go back to the, chapter 1 to talk about how bad it was, right? What determines whether or not you have to do a mitigation?
Previous layers failed.
This was, I think it's chapter 1, actually. I'll go pull it up. with this chart? So you have to categorize this event. You categorize it in terms of the, human health impact, the fire or explosion impact, chemical impact, severity. So which one is it in terms of the human health impact? Is there a possible fatality, employee fatalities likely? Did you have a seal go out on a pump? I mean, I guess somebody could go slip in it and fall down and hit their head and die, right? That's called the paperclip theory that you know, somebody could die because they slipped on a paperclip. Is it likely? Would it go in this? No. So probably not a possible fatality. Was it caught on fire somehow? Would it be a lost injury, lost time injury, or reportable because you did this? What? So, yeah. They could break their, I thought that's what you said. Okay. How much would it cost? Honestly, I put it down here. But then how likely is it to happen?
In the amount of time, so it's 10% chance every year. Like it's probably likely.
So likely.
So we might put it down at the bottom here. So this, if we put it expected to happen once over the life of the plant, no additional safeguards required. On the other hand, if we expect it to happen several times over the life of the plant, then maybe you need it, maybe you need something. I find it hard to get excited over honestly. Because it happens too often. Different pumps. And they do that. Yeah, we should have found a better one for that. Here's, let's see what they got. So they got a cooling water failure. But they're not saying, they haven't said what's acceptable. Okay. They just calculated what's the failure per year. So cooling water failure, 101 per year. And then you have a couple of items, a couple of probability of failure on maintenance protections for the basic process control system and human response. So that gets you down to 10 minus 3 failures per year. And so the real question is, what's the category that you find yourself in when the cooling water fails? Which category? Because it was 10 to the minus 3. So 10 to the minus 3 puts it here. So what is your cost? Are you expecting a recordable injury? Is there a chemical impact? If you put that down here, if you say that it belongs down here at a minor severity category, then 10 to the minus 3 is okay. Now, if we found something that was at a higher level of severity, we're analyzing it, you might have to go 10 to minus 5. And how do you get from like 10 to minus 3 to 10 to minus 5? That's a CO2 system. You have to get a safety system at a CO2 level to get from 10 to minus 3 to 10 to minus 5. Because you would come in, you would multiply the probability of failures with the demand of your mitigation system. You came up with 10 to the minus 3. Now let's say you needed 10 to the minus 5. You need to multiply by 10 to the minus 2, don't you? Well, where do you get the 10 to the minus 2? You get it from a CO2 system. And these are common, the CO2 system is what you commonly see as safety instrumented systems on our plant. They normally do not do a seal-free system because it's expensive. They can put in CO2 system. Usually it's redundant. And why is it redundant? Well, because of your probabilities. Here's a shutdown system where you have 1 out of 1 voting, and so it's 0.01 for a false shutdown, 0.02 for a failure on demand. That's not very good. If you want to reduce the failure on demand rate, you put 2 sensors and you say 1 out of 2 will shut you down. And so that reduces your failure on demand probability, but it doubles your false shutdown probability. So then you say, well, maybe I should have made them 2 out of 2 voting, so they both have to tell me. And that reduces the false shutdown rate, but the failure on demand is twice as big. Because they both have to be working for that to shut you down. So what you do most commonly is you have three measurements, and you do 2 out of 3 voting. That reduces the false shutdown and the failure on demand both over a 1 out of 1 voting system. Has anybody ever seen a 2 out of 3 voting shutdown system? Virtually every plant, that's what they do. They have 3 measurements that come in. They're completely independent of the DCS. They go straight into the safe instrument system. And then the logic does 2 out of 3 voting. So if you wondered why they did that, that's why. is because one out of one voting is not good enough. So the next reasonable thing to do is 2 out of 3 votes. Okay, well. They do have some other Lopas. There's a couple examples of Lopas, and maybe these will help you to come up with a Lopa idea for your project, if you're the safety person. So I suggest you might want to look at 12-8C. You definitely have to have something talking about HAZOPs and Lopas. Whoever your safety person is, you really need it. That's the last thing that I have to tell you, right? You have any questions about it? I mean, time's up, but do you have any questions about it? Oh, Monday, where do we meet? What? Not in here. At S&T 203, what time is it open? What time are you gonna want, if you're gonna talk at 1 o'clock, what time are you gonna wanna go over there?
Are we talking about that?
You're not, you're just gonna show me that you can put your slides up on the screen. Everybody has to come in and show me their slides, and each group has to show me their poster.
So we need to be there at 1.
I would suggest that you be there when you think you need to be there on Wednesday. And if you're gonna start at 1, then 1 is probably too late.
We're the last group, so we'll probably just get there at 1.
You can't do that, because you gotta get your stuff ready to go. You can't get your stuff ready to go after people have already started talking.
But how are we gonna get ready to go if there's 3 groups ahead of us?
You do it before the talk starts. Y'all have to figure this out, okay? 12:30. We have a room at 12:30. Okay? So you can get there at 12:30 on, Monday, 12:30 p.m., check everything out. Once you show me your slides on the screen, then I mark you off the list and you're free to go. Don't wait too long. Cause if there's nobody there, I'm not gonna hang around, so I'll just say, oh, well, they just didn't show up. It'll be more entertaining when it happens, on Wednesday. Hopefully it won't happen on Wednesday. You never know. 12:30. 12:30 Monday. And you figure out that room, okay? Figure out what you're gonna do. Any other questions? Nobody even asked me that. Why am I telling you this? I'm giving you too much information. It's all your stuff.